Good day, students. Welcome to mathgotserved.com. And this clip we're going to be going over part 3 on how to apply the chain rule in finding the derivatives. We're going to be looking at composite functions involving trigonometric functions in this presentation. Don't forget there are 6 practice problems at the end of this tutorial that I would like you to try out in order to demonstrate mastery of the contents covered. And if you'd like to gain access to our entire collection of presentations, just take a look at the link in the description below. Alrighty, let's get started by reviewing what the formula for the chain rule differentiation process is. So the formula for the chain rule differentiation process is if you have the composite function, let's say it's f composed with g of x, okay, and you want to find the derivative with respect to x of this composite function. So it's going to be the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Okay, so let's write that out. So we're looking for the derivative of the outer function evaluated at the inner, so you differentiate one at a time. Okay, when you're differentiating the outer function, you do not differentiate the inner function at that point in time, because what you do is you differentiate the outer and put the inner in it. Okay, and then you multiply what you get by the derivative times the derivative of the inner. Okay, all right, so in short, we're gonna just refer to this as DOEIDI. All right, so we're just going to DOEIDI the problems that we're doing today. Derivative of outer evaluated at the inner times the derivative of the inner. All right, let's take a look at some examples. The instructions for the problems we're doing, problems 1 to 6, is to find the derivative of the functions. Find the derivative of the functions with respect to the independent variable. Okay, we're going to be changing variables quite a bit here, so we want to let you know exactly what we're differentiating with respect to. Okay, so we're going to be differentiating with respect to the independent variable. All right, so for question number 1, let's say we have a function y is equal to sine 4x to the third, and we're to find dy dx. All right, let's do it. All right, so if you take a look at what we have here, you notice that we have a composite function. Okay, y is equal to, I'm going to color code this so you can see what's going on. Y is equal to sine composed with the cubic monomial 4x to the third. Okay, so to find the derivative, we're going to use the chain rule. So what we're going to do is we're going to decompose, differentiate, and recompose our result using the chain rule formula. Okay, so let's decompose it. The outer function, let's call that f. So f of x is sine x. And then the inner function, let's call that g. Okay, some textbooks refer to that as u, doesn't really matter. So we're just going to call that g. G of x is equal to 4x to the third. Now, decompose and then differentiate, okay? So we're going to differentiate both functions. So f prime of x is equal to the derivative of sine is cosine x. And then the derivative of g, 4x to the third, using the power rule, is you power down 3 times 4, 12, x to the, reduce the power by 1, or subtract 1 from the power, 12x squared. Okay. Now using the chain rule differentiation formula, this is how we're going to go about this. We're going to find the derivative of the outer evaluated at the inner. So we're going to plug in the inner function into the derivative of the outer and multiply it by the derivative of the inner. Okay. So our final answer in unsimplified form, dy dx is going to be cosine of, and it will put in the inner function, cosine of 4x to the third multiplied by the derivative of the inner function. So let's rewrite it in standard format. So the polynomials come first before the trig functions, okay? So DOEIDI x is 12x squared cosine 4x to the third. And that's the answer to question number 1. All right, let's take a look at number 2. So for question number 2, let's say we have the following function. So if h of w is equal to cosine w to the fourth, then h prime of w is equal to, so let's go ahead and find that out. Okay, so what do we have here? So we start with h of w. So h of w is cosine w to the fourth. So I'm going to color code my composite function so we can easily apply the chain rule differentiation technique here. All right, cosine w to the fourth. All right, so first things first, we're going to decompose, differentiate, and recompose using the chain rule formula, or DOEIDI. Alrighty, so let's decompose. The outer function, we're going to call that f of x, which is cosine x. We're doing exactly what we did here, so you can refer to that to review if you want. And then the inner function is the quartic monomial w to the fourth power. So g of x is w to the fourth. So we've decomposed the functions. Now let's go ahead and differentiate them. So f prime of x. So when you differentiate cosine, remember, it's a c trig function, so you can have negative sine x. And then if you differentiate g, applying the power rule, power down, 4w to the power minus 1/3. So using the chain rule to finish this off, we're going to have the derivative of the outer evaluated at the inner. So plug the inner in it, times the derivative of the inner function. So let's see, h prime of w is equal to negative sine. So derivative of the outer is negative sine composed with the inner function, the original inner, okay, times the derivative of the inner function, which is 4w to the third. And then we'll write this in standard format. Our derivative, h prime of w, is going to be, so the polynomial comes first, okay? So negative 4w to the third sine w to the fourth. And that's the answer for question number 2. Alrighty, let's take a look at number 3. So for question 3, number 3, if f of s is equal to tan s squared, find the rate of change of f with respect to with respect to s. Okay, so let's go ahead and do that. All right, so if you're asked to find the rate of change, what does that mean? How do you find the rate of change? So let's write down Navier-Stiller real quick. So we have Navier-Stiller. All right, so we know that if you're looking for the rate of change, as we're asked to find here, the ROC, or instantaneous rate of change, it's the same thing as finding the derivative. All right, so rate of change is the same thing as finding the derivative. It's the same thing as the slope of the tangent line, okay? All right, so in this particular problem, this is the same thing as finding, you're actually looking for f prime of s. So what we want to do here is want to find f prime of s. Okay? All right, let's do it. So f of s is tan of s to the fourth power. Okay, now we're going to use the chain rule here. Let's decompose the function. The outer function f of s is tan s, and then the inner function g of s is s to the fourth. Okay, so imagine as though x were s, same thing. Okay, all right, so we'll differentiate both. The derivative of f with respect to s, the derivative of tan is secant square, so it's going to be secant square s. And then using the power rule, the derivative of s to the fourth is 4s to the third. Okay. Oh, it looks like I changed the problem. Yes, I did. All right, let's make a real quick correction here. So this should be s to the second power. So now change the derivative. All right, sorry about that. So this is supposed to be s squared, so the derivative will be 2s, like that. Okay, so now let's go ahead and recompose the function using the chain rule. So f prime of s, the rate of change of f with respect to s, is going to be secant. So you're going to find the derivative of the outer evaluated at the inner. So plug the inner into the derivative of the outer times the derivative of the inner. Okay, so it's going to be secant square s square times 2s. And there you have it. Let's write it in standard format. F prime of s is going to be 2s secant square s square. And that is the answer to question number 3. All right, let's take a look at question number 4. So for question 4, what if you have the following situation? If f of s, let's change this, let's use g this time. So number 4, let's say if g is equal to cosecant 4s to the fifth, then dg ds is what? Okay, let's go ahead and do this one real quick. Okay, so now we have our composite function. G is a function of s. Okay, so g of s is equal to cosecant 4s to the fifth. So we're going to decompose. All right, so the outer function, we'll call it f. So f of s is cosecant s. And then the inner function is going to be g of s. We're going to call that 4s to the fifth power. All right. So let's go ahead and differentiate both. F prime of s, the derivative of cosecant is cosecant s cotangent s. So it's going to be cosecant s cotangent s. And then the derivative of the inner function is going to be, you power down 5 times 4 is 20, s to the fourth. All right, so we'll pull it all together using the chain rule. dg ds is going to be the derivative of the outer evaluated at the inner. So we're going to plug in this into the independent variable spots here. So we're going to plug g into this s right here and into this s right here. Okay, so it's going to become, what is it going to become? The GDS is going to be cosecant 4s to the fifth cotangent 4s to the fifth. All right, times the derivative of the inner. All right, that's what the chain rule is. Derivative of the inner is 20s to the fifth. Okay, so actually the derivative of cosecant is negative cosecant x cotangent x. So there's a negative component there. So we don't want to forget that. All right, so let's put it all together. The final answer, dg ds, is going to be the polynomial comes first. It's going to be negative 20s to the fifth cosecant 4s to the fifth times, you can put the parentheses if you want, sometimes it's not necessary, times cotangent 4s to the fifth power. And that's the answer to question number 4. All right, moving right along. Question number 5. Let's say you have the following situation. Find dy dx when y is equal to secant 2x squared. Okay? All right, so let's go ahead and do that. So we have y is equal to secant 2x squared. We're going to decompose it. Alrighty, so f of x is secant x. That's the outer function. And then the inner function, g of x, is 2x squared. Differentiate both of them. The derivative of secant is secant x tan x. And then the derivative of g is going to be 4x. It's just going to be 4x. All right. So let's put it together using the chain rule. Derivative of outer evaluated at the inner. So this will be going in here and there in the x's of the f of f prime multiplied by the derivative of the inner function. So we have, what are we looking for? dy dx. dy dx is equal to secant 2x squared tan 2x squared times 4x. Okay, so the final answer in standard format is 4x secant 2x squared tan 2x squared. All right, so that's the answer to problem number 5. Let's take a look at one more and give you a chance to do some practice problems. Okay, so for question number 6, let's say you have the following situation. Number 6. If y is equal to cotangent 3x to the fifth, find dy dx. All right, let's do that. So if we have y equals cotangent 3x to the fifth power, we're going to decompose this, okay? All right, so the outer function f of x is going to be cotangent x. So that's the outer function. And then the inner function is your quintic monomial right here. We call that g. G of x is 3x to the fifth. All right, so let's go ahead and differentiate both of them. So the derivative of cotangent, this is another c function. So remember the negative cosecant square x. And then the derivative of the inner function, our quintic monomial here, is 15x to the fourth. All right, so we have the derivative of the outer evaluated at the inner, so plug in the inner into the derivative of the outer times the derivative of the inner. Okay, so dy dx is going to be, so negative cosecant square x, so in place of x, we plug in the inner function times the derivative of the inner. And if we write this in standard format, with the polynomial function first, we have dy dx is equal to negative 15x to the fourth cosecant square 3x to the fifth. Alrighty, so there goes the answer to question number 6. Alright, so now it's your turn to work on the following practice problems. There are 6 of them. The goal here is to find the derivative with respect to the independent variable. Go ahead and pause this video presentation at this time. Differentiate all 6 functions, and when you're done, click on the play button and we will show you what the answers are. Alrighty, welcome back. Hopefully you had a chance to try out the problems. So here are the solutions. For number 1, dy dx is equal to negative 6x squared sine 2x to the third. And for number 2, g prime of s is negative 25s to the fourth power sine 5s to the fifth power. For number 3, the derivative g prime of w is 5w to the fourth power cosine w to the fifth. Moving on, for number 4, the derivative is the r dt, or r prime, doesn't really matter, is negative 4t cosecant 2t square cotangent 2t square. For number 5, the derivative, dy dx, is 10x to the fourth power secant 2x to the fifth tan 2x to the fifth. And for number 6, the last one, dy dx is negative 12x squared cosecant square 4x to the third. Alrighty, so how well did you do on these 6 practice problems? Let's know in the comment section below. If you have any questions about what we just covered or any chain rule differentiation question in general, just post your questions in the comment section below and we'll be more than glad to assist. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of the chain rule, do give us a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other presentations such as this. If you have any questions or comments, just post in the comment section below and we'll be more than glad to respond. To gain access to our entire collection, you can look at the link in the description, or you can just visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.